Does the audio work? Does the audio work? The audio does work. Woohoo! My microphone's still broken, so I'm gonna be a little bit kooky. So I have this one up. Okay, I'm just gonna fix this one up. So we'll do it with the composites today. So I don't know how many people have looked at composite functions, or how many of you have seen composite functions, or if you're good at them. A lot of people tend to suck at them because they suck, right? They're probably one of the hardest things they're probably one of the hardest things to explain, right, for most people, because they really don't like explaining this one. So let's go. I'm gonna open one of these things up real quick. I'm just gonna create a copy of this one. So yeah, you'll see a couple cars coming up from behind the blinds. So yeah, that'll be fun. You guys get to watch that. So, how has everyone been this afternoon? I don't know if I have any. I think I'm talking to a brick wall right now. But yeah. So I'm gonna try and run these as much as possible. It depends on the timings though, because I'm very bad at time. I don't have much time. Uni's very busy, bro. But I'm trying to run as many of these as possible, sort of just like explain the ideas and that sort of thing. And if you guys just want a little background behind me, I do maths. Yeah, I'm pretty cool like that. You know, I use a calculator sometimes. You know, calc shop for calculator, that sort of thing. But hey, some of us are pretty cool, some of us ain't. You know, and we'll see how it all pans out. So we're gonna do composite functions today because I personally hate having to explain this because I think people just suck at explaining it, and I think they're a lot easier than people tend to think they are. Yeah. Now, well, one of the hard parts about composite functions is that people don't actually have the basic skill of just graphing. Yeah, and I think people underestimate how valuable graphing is going to be. Yeah, because when you know how to graph, you can do 95% of any question. Yeah, because half the difficulty in half these questions is going to be related to, well, freaking graphing. Yeah, that's just the nature of these. Yeah, so how do we get around that? That's the real question. You know, how do we fix that? How do we make sure that it's not a problem to graph? Well, it's by knowing all your graphs, and it's a bit hard to know all your graphs. You're probably thinking to yourself, Jason, I don't know all my graphs, right? Like if I bet I could turn to most people, they won't be able to tell me what are all of their basic graphs. Like what are all their basic graphs? What are their shapes? You know, how can I sketch them really easy? That sort of thing. Yeah, and one of the things that I like to always go through is the gallery of graphs. I don't know if anyone remembers it from year 11, but the gallery of graphs is a very powerful tool that people don't tend to use enough. That's my personal belief behind it. I think it's one of the best things to use. So let me just pull that one up as well. I'm gonna find it on my computer. I'm finding this one on the computer real quick. Give me a second. It's all here. Let me just pull up methods, Cambridge, and we'll use this one. That's the one, right? So, a lot of people suck at this one, mostly because it doesn't show up in year 12. They don't reteach the gallery of graphs, right? They sort of, this is, okay. And this is where I find that, like, some of people's knowledge ends, because the thing is, they chose not to really give a shit in year 11, which is fair enough. You know, like, most people don't really want to care that much in year 11. But then, like, when they try and do it in year 12, they're like, aha, but I don't know how to do this no more. And then I'm like, yeah, it's kind of helpful to know how to do them. So, let me just switch over the screen real quick. We'll look at this one. And we'll have a look at these questions here, yeah? So, here, we have some of our options of our basic graphs, right? We have rectangular hyperbola. We have truncus, right? Spelt with a W, so it's spelled truncus, like so. And we don't have this one. This one is taught implicitly for special. We have our square root graph, right? And we have all the transform versions of those ones, yeah? So how can we apply the transformations on them? How can we do these transformations? And the other graphs that we have. Well, what are the other graphs that we have? I've looked at a couple of them over here, right? But let's remember some of our other ones. We have our y equals mx plus c, right? Which is just our straight line graph. It's going to look something like this, yeah? We're going to have our quadratic function, which is going to look something like this. Y equals ax take away h squared plus k, right? It's going to look something like this, where this turning point is just going to be h comma k. We also have down here, we have our cubic graph. Our cubic graph is going to be the same thing as, well, it's going to have the rule y equals ax take away h cubed plus k, yeah? We also have over here our quadratic, our quartic. This one's going to have the rule of, this one, these turning points are still h comma k. This turning point here is h comma k. This is going to have the rule y equals ax take away h to the fourth power plus k. Is that making sense so far? Any questions, comments, concerns? If you have any questions, comments, concerns, please either message me on Discord if you have my Discord, or message me on what's it called? Go to them program. Okay. I'm just reading something on the Discord. I just find it pretty interesting. Anyway, if you have any questions about that so far, does that make sense? So I'm just stating for the basic equations of each one of these lines. So we've done the truncus, we've done this, we've done that. The other things that we might have to know about, we might also have to know about, well, our y equals, you know, ax plus ax take h to the third power plus k, yeah, which is going to look something like this. We might also have here, we also have our y equals sine of x, you know, our y equals cos of x, and y equals tan of x, right? Which is just some of our function, which are trig functions, our three trig functions that we have to know methods, yeah? So it's going to look something like this, each one of them, yeah? And I would suggest one of the best ways to practice this is, if you want, I can make a video about all of these, or I can do a live stream about these. I think learning how to do these is one of the most valuable skills you can have, yeah? Because if you don't know how to do them, you're kind of cooked. Am I paused over here? Okay. You're kind of cooked if you don't know how to do any of them. So, how many do we have so far? Well, here we have, we're looking at 1, 2, 3, right? And then we keep going down. You know, we have here 4, 5, 6, 7, 8, 9, 10, 11, and our 12th graph. Our 12th and 13th are going to be our log graph and our exponential graph. So y equals ln of x, and y equals e to the x, right? So those are our functions. Now, why do I believe they are valuable to look at? Why do I think they're important? Why do I think they're good? And the reason I think they're very valuable to all know is because they're very vital when we do composite functions. Now you're probably thinking to yourself, well, what is composite functions? Yeah. So, you're thinking to yourself, well, what is a composite function? And I'll start off by this. Yeah. How I've started this off. I want to preface to all of you that the first thing you have to know before you touch composite functions is you should be able to sketch every single graph, right? I don't care how slowly you can do it. I just want you to be able to give a basic sketch of all of these graphs. I don't need you to, flourish it with unicorns, put arrows, put endpoints, draw asymptotes, all this other stuff. I just want you to know what they look like. And I want you to know their ranges and domains. Because it will become very important in composites, right? Now, unless the graph that they give you composite of is something you can sketch, generally, composite functions only deal with the ideas of the range and domain. The VC realistically can't ask you to sketch a function you don't know what it looks like. Like, for example, it can't realistically ask you to sketch the graph, well, sine squared of x, right? Because they haven't given you the tools equipped to sketch sine squared of x. I can do sine squared of x because I'm just such a goat at maths, right? But a lot of other people won't be able to do sine squared of x, which is completely fine, right? But here, what am I trying to get at? Composite functions. Their expectation on an exam 1 is that you can find the domain and the range of a composite function, yeah? In exam 2, they can ask you whatever because you have a calculator. So those are the two different points, yeah? Exam 2, right? You will need to utilize your skills a little bit more and find like the domain and range. Exam 1, you just use the domain and range of simple functions. So let's get into this. Let's get into this part, right? And let's get into why composites are so interesting, yeah? So when we generally think of a function, we think about it in terms of a number machine. Now, this is why I think a lot of people go wrong. They always struggle with this number machine explanation, yeah? And here, so we start off with a number machine. We have f of x, we have our input. We call this x, right? And when we input a number into our number machine, here we've inputted 3, we'll get some sort of output out, right? Here, this is what our number machine is defined as, yeah? So if I put x in there, I get an output of 11. So that's the first part of our number machine. Now, our second part of our number machine is going to be, well, here. Instead of just having 1, what happens if we have a second one, yeah? We have a second one. So here we can think about it as, well, we first put our we first put an input into f, right? And we follow this rule. We get an output of 11, yeah? We put this output back into G, another machine. You can think about it as a line. You don't have one machine in a line. You have multiple, yeah? So we go from 11, and we'll, following the rule of G, we'll get our output 121. Now, why does this analogy matter, right? And the reason it matters is because it will help me explain some of these rules that we deal with later, some of the definitions that we have. So, let's have a look at it. This is illustrated on the right. So we've illustrated it on the right. And here we can see that when we want to write out this new function, right, it is just going to be, well, g of f of x, right? You can think about it as, well, I'm putting a number into f of x. I'm getting an output, and I'm putting the output of f of the machine f is f of x, right? So I put f of x into g of x. I'm thinking, instead of here I have x, I output here f of x. I put f of x into g of x, and I get the output g of f of x. Does that make sense? So that this is just using the basic number machine logic, yeah, behind this. And it sounds a little bit silly because, I don't think I've seen many teachers really use this idea of the number machine. They sort of just they do it and then they're like, oh, well, fuck, I guess I'm screwed, yeah? So now we'll build upon this, right? We'll build upon this by going through this idea. So here we can represent all composite functions, h of x, as g of f of x, or an alternative notation you might see is G, O, F, right? We can see both of these notations here. So we'll see this. So here in the example above, this is what we consider the number machine as. So it's h of x equals g of f of x. F of x in this case is another way of saying our inside function, yeah? And g of x is just our outside function. So our first machine, and then our second machine, yeah? So does that make sense, right? I'm just using previous theory, and you do have to understand f of x and g of x notation. But it's pretty simple to explain after this. Does that make sense? Any questions about that? Any comments, any concerns? If there are none, I'll continue going on. So we'll continue building on it. And there's a couple fundamental properties here, right? We have this one. The range of f is a subset of the domain of G. This is a fundamental property of all composite functions. Of all composite functions, this is a fundamental property, yeah? This here isn't a fundamental property, and I'll explain why, yeah? And this is also another fundamental property. So this is the notation that we had before. Now, what is the range of f is whatever this weird symbol, domain of G. What the hell does that even mean, yeah? Essentially what that's saying is that, here, this weird symbol means subset. So the range of f is a subset of G. Now, a lot of people like to use this stupid Venn diagram. This means nothing. So I'll give you an example, yeah? Imagine the range of f is, let's just say it's 1, 2, 3, and 4. Now, what I'm saying here is if I plot this all in a number line, right? I have it 0, 1, 0, 1, 2, 3, and 4, right? I have here 1, 2, 3, and 4. Yeah? These are the outputs I can get of f. That's what range means. Range is the outputs. So the possible outputs I can get here are going to be 1, 2, 3, and 4. Well, what's the domain? Yeah? Let's just say we have the domain of G. And the domain of G is also 1, 2, 3, 4. Let's just say it's also 5. Right? That means here, if I wanted to write out G, it's going to be 1, 2, 3, 4, and I'll put 5 on the side. This is 5. Now, what it means to be a subset is that, well, I can, f of x's range, right, can be written as part of g of x's, yeah? So, here I have 1, 2, 3, and 4, right? It's inside of g of x's domain, yeah? So, for example, if I had 0 here, yeah? Let me just remove some stuff really quickly. If I had 0 here, then, well, if I have 0 here, then it's not a subset, because I can't write all of the values of f, right? Because there's a 0, yeah? I can't write all of the values of f in G, right? They're not in G. Does that make sense? So here, the range are all the outputs of f, yeah? And that has to be a subset. It has to be contained inside of the domain of G. So basically, any of the outputs of f must also be the inputs of G. Any questions about that? Any comments? Any concerns? If there's not, I'll continue going on. But does that make sense? So, I'll continue building upon this, right? Sure, I'm sharing the theory in your head, but I want you, we'll have a go at some practice questions. And I want to explain the practice questions. First, we'll look at some of the examples that they have, yeah? I think these examples are somewhat poor, but they will demonstrate a point that I want to show, yeah? But before I get onto these examples, I want to state something. There's two types of composite functions, yeah? There's the ones that exist, and there's the ones that don't exist. The ones that exist follow this property. So it follows this range is a subset of the domain, yeah? Of G, yeah? Well, from here, this will imply for us that here, the domain of our composite, G of f, is going to be the same thing as our domain of f. here, if it doesn't exist, well, it means that the range of f is not a subset of the domain of G. And that means here we can't necessarily use this property. So we're going to have another way. So that we've broken down our composite function questions into two different types. Yeah, the ones where the range of the range of f is already a subset of the domain, and here we have the second one where they don't exist. And here we're going to have to change the domain of f so that here we do get this property, right? That's the whole point. For composite functions, the majority of composites by hand focus on this property. So let's have a look at some questions. Yeah. So here we'll first have a look at this one, right? Find both f of g and g of f, stating the domain and range of each. Well, what's f of g? F of g is the same thing as f of g of x. Well, what's g of x here? Yeah, g of x is just equal to, so we have f of 3x squared, which is just the same thing as 2 3x squared take away 1, right? If we expand this out, we get 6x squared take 1. Then we have g of f, yeah? G of f is just the same thing as g of f of x, which means here we're going to have g of 2x take away 1, which is the same thing as 2x take away 1 squared. Yeah? So this is our rule of our function. Yeah? We're going to have a look at finding this range part in a second. But let's first deal with the domain. Yeah? Well, what is the domain of this function? Yeah? The domain of this function, the domain of the first order, this function, well, let's first check. Well, what is the range of, here for this one, what's the range of f? It's going to be it's going to be from 0 to infinity. Here, this is where my skill of graphing comes in. If I'm able to sketch this one, yeah, I can realize it's from 0 to infinity, right? Over here, this one's domain is all real values, right? Which means, right, the best way to show if something's a subset, I like to always use number lines, yeah? So if I go up here, right, I draw this out, right? I have the domain of G at the bottom, so I put this all out here, right? And then I put here the range of f. Well, I can see that this line is inside of this line, yeah? Which means it's a subset. So here, the domain of f of g is just going to be the domain of g. It's going to be all real values. So the x values for this one are going to be all real. For this second one down here, right? Well, what's going to be the domain of that one? The domain of this one is going to be, well, let's do the same test again. Well, here we have the domain. Here we're trying to find the range of this function. The range, this is a regular linear equation. It's going to just look like this, right? It's going to be all real values again. This is its range. The domain of this one is also all reals. And again, if we want to show that's a subset, right? Well, all real numbers is always going to be inside all real numbers. So they're subsets of one another. Does that make sense? Any questions, comments, concerns? If there's no questions, I'll continue going on. So we can say here, the f of g of x, the domain of this one, is also going to be all reals. Now, well, what am I going to do from here? Yeah? Now it wants me to find the range of each one of these. Yeah? And the range is a little bit harder. So I'm going to use this little table that I'm gonna invent over here. So we have the domain. Yeah? So we're going to have our table here. I'll put range here. Just be mindful I'm writing over this. Here. So here's our domain, here's our range, right? And let's just say we want to find the range of this function, yeah? We put g at the top because it's our inside, and we put f at the bottom because it's our outside, yeah? Now from here, right, we want to just fill in, we want to start off by filling in this first part, yeah? So here we'll start off with all reals, right? But then it's all real positives. It's all real positive values, including 0. So just remember, This just means the exact same thing as this. Yeah? Now, what we want to think of is that, let's go back to our number machine analogy for a second. Yeah? These are the outputs of G. And I'm putting all the outputs of G into my outside function. Yeah? Which means these are going to be my new outputs of my outside function. It's weird, isn't it? It's weird because like the subset thing, the subset would imply that, you know, we're using the same domain, but we're not, right? We're inputting all of the values of the inside function into our outside. So these are the possible values we can have in our inside, in our outside function. Yeah. So here is our outside function. Here's f, and let's try and sketch it over this domain. Well, it's going to look something like this. Yeah. Where we start off at 0, -1, and we get our final answer. We get here -1 to infinity. So here, the domain of this function is going to be -1 to infinity. So here we have, this is the range of this function, right? So here we're going to put, well, y is an element from -1 to infinity. Does that make sense? Any questions behind that? Now, I can do the same process for G, yeah? If I do the same process for G, I write at the same table. So we have a DOM, I'll put rang, just to simplify it. You know, we're mathematicians, we don't really care too much about spelling. Here we have G, here we have F, right? We start off now, oh wait, no, it's the other way around, my bad. So we have here F, G, right? So we start off with F, and we have G at the bottom, right? The domain of this is all reals. The range of this one is all reals. The outputs of G are now also all reals, yeah? No, it's the same as it was before. Over here, the range of this one is going to be, well, it's going to be from all real values, including 0. Which is just, you know, if I sketch this function out, that's what its range is going to be under this domain, yeah? So this concept is very foreign to a lot of people, yeah? This idea that I'm shedding to you is the thing that people always find very confusing, yeah? It's this like Wii emotion. And well, why does it work like that? It works like that for the explicit fact that, well, think about it. I'm putting all of the outputs, right, the range of the inside function, or the first machine, into the second one, yeah? So that's why we have that motion. Does that make sense? So any comments, any questions, any concerns about that? Now here we can use the TI inspire to find the range of this function, yeah? And again, we can use the TI, and we can use Casio classpan as well, right? Now, we want to figure out whether a function is defined. And to show that a function is defined, well, we need to remember that here, we want to state which of the following is defined. We use the property, well, the inside function's range must be a subset of the outside function's domain. So what's this inside function's range? Well, this one here, well, the domain of this one's all reals. Yeah, so this is the domain. This is the range of this function is going to also be all reals. The domain of this one is going to be x is an element of from 0 to infinity. And the range of this one is also going to be from 0 to infinity. Yeah? So, here, we can see that for f of g, right, is all real numbers a subset from 0 to infinity? Well, we can show this one by here. We draw a sketch here, right? This is our inside function. So this is our outside function. So we want to draw it like so. Yeah? This is our inside function. And do you see how I can't actually write this one inside of this one, yeah, on my number line? So it's not, yeah? So f of g is not defined, right? Because for the explicit purpose, right, it's not defined because this subset rule isn't applied, where here the range of g is not a subset of the domain of f, yeah? If I try and do it the opposite way around, I'm trying to show you this one. Well, I take the range of f and the domain of g. Well, the range of f is from 0 to infinity, yeah? And the domain of f is going to be, the range of g, the domain of g is going to be all real positives, yeah? This is a subset of this, right? Again, if I put it on my number line, yeah? I'm using number lines a lot, yeah? I like using the number lines for composites. So here we get g of f is defined. So I'm showing it's defined, yeah? Does that make sense? Yeah? And now, for the composite that's defined, state the domain of the rule, right? And the best part about this is that here, right, we can use this existence rule, yeah? Well, if this existence rule is true, that means the domain of g of f is just the domain of f. We don't have to manipulate it anyway. So here I can simply just do, I can do here, they do here f of g, which is the same thing as g of the square root of x, which is the same thing as 2 square root x, take 1. And we have the domain here, which is g of f, is equal to f, which is all reals, yeah? Because this is in the case where it exists, yeah? Now, in the case where it doesn't exist, we'll get to that in a second. We'll get to the case where it doesn't exist in a second. But I think it's a very interesting property, yeah? I think it's a remarkable property. And we'll keep going on with these ones, yeah? So, here. This is where we start dealing with the situation where it's not defined. This is the situation where it's not defined, right? And in the situation where it's not defined, right? Well, we want to state why it's not defined. Well, here, what's the range of f? Let's find the range of f. Again, I sketched this function over all reals. This is what it looks like, yeah? It's going to go from -1 to infinity. What about this one, yeah? This one is going to go from 0 to infinity, yeah? So here, right, this compass is not defined because if I draw both of these out on a number line, well, what I'm going to get is well, here is going to be the inside function, right? And this is going to be 0. This is going to be from -1, and it's going all the way to infinity. And do you see how this one isn't inside of the second line? Yeah? So that means they're not subsets of one another. Does that make sense? So here, we can then say that here, -1 to infinity is not a subset from 0 to infinity. They're not inside each other. So, let's now figure out a way. Now let's talk about the method by which we can restrict it. We're going to use our same table, yeah? So I'll zoom in a little bit here. So we'll use that table. So here, let's pull out a table. We have our domain, and we have our range table. And if we draw both of these two out, right, what we will get here is, I'm going to draw this sort of grid, yeah? Here, we're looking for the function f of g. So what we're going to have to do is, when we restrict it, we're restricting the domain of f, yeah? Restricting this array in a way such that the range of f is a subset of g, yeah? Domain of g. So how can we restrict it in that way? Let's try and do that, yeah? So the first thing we're going to have a look at, yeah? This is the domain of g, yeah? This is the range of f, yeah? How can I make them subsets of each other? How can I make them subsets of each other? That's the real question, yeah? How I can make them subsets of one another is I'm going to draw them both on a number line, yeah? So 0. So this one's the range, this is the domain of g. This is the range of f, yeah? Essentially, where can I cut them off where they're subsets of each other? Or what's the largest place I can cut them off where they're a subset of each other? And I can cut it off at 0. So here, I can make it this line. So I'm forcing the range of this one to go from 0 to infinity now, yeah? I'm forcing this one. This one's also going to be from 0 to infinity, yeah? So it drags it down. Does that make sense, right? Now that we have this, we can sketch out g, we can sketch out f, yeah? So this is what f looks like without any restrictions. Now, I want to restrict the range in such a way that, well, here, now, I'm going to restrict it in such a way that we want it to be going from y equals 0 all the way to infinity, which means we want all of this blue part, yeah? And here, I can solve, well, when it's equal to here, right? So when it's equal to here, this is going to be at -1. This here is going to be equal to 1. That means I want the points from -infinity to -1, inclusive, because I can accept the point at 0, union the point from 1 to infinity. Does that make sense? So here, for our composite, I've restricted the range. And this is the new domain of it now. So, what's the takeaway here? Because we're going to get into some questions now, yeah? And we're going to just start dealing with more and more questions. So what are we doing first? So what am I trying to do here? That's the real question. The first part, yeah? I'm trying to find the rule of the composite. The next part is if it satisfies this rule without me having to change it. The domain of G is a subset. A domain of G of F is the same thing as the domain of F. I've shown that here. To find the range of a composite function, I must use this table where I use this little wee motion to get my answer. Yeah? And I find it by I find it by doing this. Yeah? For when it's defined and not defined, I'm just trying to prove if it's a subset or not. Yeah? And if it's a subset, again, I can find which one's defined. Yeah? If I go to this last part, right? We're showing it's not defined. It's not a subset. We're trying to show it's not a subset. Now, how can we make it a subset? That's the real question. Yeah? We want the range of f to be a subset of G. I'm artificially reducing the range of f here. Yeah? And by artificially reducing the range, I must reduce the domain of f as well. Does that make sense? Does that make sense? Any questions, any comments, any concerns about this? I've broken it up in such a way. I've tried to break it up in such a way that it's a little bit more digestible to follow. Yeah? And I'm going to say it now, it's very hard in the beginning. Yeah? Because there's a lot of things you have to think about. But when you get more and more used to it, you'll get better and better at it. Right? So I encourage you to have a look at this stuff. I'm going to keep going. We're going to have a go at some questions now. Yeah? Well, here. Let's have a go at some of these ones, yeah? So here, right? Question 1. We're trying to find, question 1a, right? We're trying to find f of g and g of f. So f of g of x, yeah? That's the same thing as f of 2x, which is the same thing as 2 brackets 2x, take away 1, which means we get 4x, take 1. If we want to find out g of f of x, right? We'll get here g of 2x take 1, which means we get 2 brackets 2x take 1, which is 4x take 2. Yeah? We can do the same thing for all these other questions here. I'm sure, like, the simplicity behind these ones is very, very interesting. Yeah? It's just the same thing over and over again, right? So if I do question B, right? I'll grab out another page for this one because I don't want to fill up the page too quickly. Well, I don't want to fill up the page too quickly. Why doesn't it come up? Why doesn't my computer like me anymore? Man, what the hell? Man, what the flick? What the hell? What the hell are you on there? What the frick? Okay. We'll try and do it. So with the second part here, yeah? We'll try and do the second part. Here we have, well, we'll try and find f of g. of x, right? Which is the same thing as f of 2x plus 1, which is the same thing as 2x plus 1 plus 1, which is the same thing as 8x plus 4 plus 1, which is the same thing as 8x plus 5. Yeah? Question D. Right? Let's just say I want to find g of f of x. Yeah? That's the same thing as g of 2x take 1, which is the same thing as 2x take 1 squared. Any questions about this? Any comments, any concerns? We'll have a look at this one now, yeah? Well, here we have f of h. This just means f of h of x, yeah? It's nothing complicated. So we get here f of 3x plus 2, which means here we have 2 brackets 3x plus 2 take 1. Here we get 6x plus 4 take 1, which is the same thing as 6x plus 3. So, yeah, does that make sense? Let's say instead we're given a number inside. We're asked to find out, well, what is f of h of 3? Well, first we have f of 3 times 3 plus 2, which is the same thing as f of 11. F of 11 is the same thing as 2 times 11 take 1, which is the same thing as 22 take 1, which is the same thing as 21. Any questions behind that? Any questions, comments, concerns at all? I think it's very interesting. But we'll see what's going on. What the hell? I'm just reading through this chat. Well, what the frick? What the frick? What the hell are they? Dude, everyone's just hating on engineering. I gotta show them some interesting double integral stuff. Anyway, it's fine. So here, question 3 goes by the same ideas, the same principles. We'll do question A. Do part A and part D. So part A, we have here f of h of x. F of h is the same thing as f of 3x plus 1. Then we get 3x plus 1 squared plus 2 3x plus 1. Yeah? Which is the same thing as 9x squared plus 6x plus 1 plus 6x plus 2. The same thing as 9x squared plus 12x plus 3. If you want to find out, well, h of f, right? We have h of f of 3, yeah? Trying to do that. Just gonna run out of stuff so it doesn't just get in the way. We get here, right? We get here h of, right, 3 squared plus 2 times 3, which is the same thing as h of 9 plus 6. Same thing as h of 15, which is the same thing as 3 times 15 plus 1, which is equal to 46. So it's nothing too complicated so far, right? Have a look at these ones, yeah? It says they state the rule and the domain, right? Let's try and state the rule and the domain of these two functions. So here, well, at first given, h of 0, h of g. So first, well, what is h of g, yeah? I'll go over this side and I'll do it over this side of the page, yeah? So here if we have h of g is the same thing as h of g of x, yeah? Now, we can rewrite this as 1 over 3x plus 2. I'm skipping a step now, yeah? I'm getting a little bit more advanced. I'm getting better at doing this, yeah? But now I want to find out what's the domain of this one. Well, first, to figure out the domain, yeah, I have to figure out whether here the range of this one is a subset of the domain of this one. Yeah, the range of this function, if I sketch it, it's on all real positives, so it's going from 0 to infinity. Yeah, not inclusive. So this is going to be 2. Oh wait, this is going to be from 2 to infinity. Yeah. And here, right, if I draw up my number line again, yeah, I realize that, well, 0 to infinity, not including this, is a subset. Well, wait, no. 2 to infinity is a subset of all rules, not including 0. So here, that means the domain of this function is going to be all real positives. Yeah, because it's just the domain of the inside. Does that make sense? Any questions, any comments, any concerns about this one? Any queries? So I'm just using all the rules that I've set up. I'm not inventing any new maths. I'm not creating any new methods, yeah? I'm just using the maths that I already know to enhance my understanding, yeah? If I look at here, question H, and I try and do this one. Well, here, well, we have g of h of x. That's what it's asking for, yeah? That's the first part. That's the rule. So g of h of x is going to be the same thing as g of 1 over x squared, which is the same thing as 3 brackets 1 over x squared plus 2, which is the same thing as 3 over x squared plus 2. Therefore, that's going to be our rule. Now, what's our domain, right? Here, well, let's find out, well, what's the range of this function? The range of this function is going to be, well, let's sketch it out really quickly. It's going to look something like this, yeah? Which means, well, the range of this one is just going to be all real positives. Yeah? It's all real positives here. Yeah? This one, that means here, well, if we sketch these two out, this is the domain of G. This is the range of H, right? They're going to be subsets of one another. Yeah? So here, X is an element of all real positives. Yeah? Oh, well, shit, no. It's going to be X is an element of all real numbers, not including 0. Yeah? So, I'm just using the same rules that I've established before. Yeah? If it's a subset, that domain rule applies, right? And if it's not a subset, well, the range rule applies. So, I might make a little notes page about this. So, let me just rub all these ones out. Okay. So, let's do this next part here. It says here, state the range of f and g. Well, here, how do we state the range for these two functions? We have to sketch them, yeah? So here, this is what f looks like, yeah? It's going from -4 to a negative, 0 comma -4, yeah? All the way to infinity. So here, f's range is going to be from -4 to infinity. What about g's? Yeah? G's is just a regular square root graph. It's going to look something like this. Yeah? So g's range is going to be from 0 to infinity. Yeah? Well, it says find f of g, stating its range. Yeah? We want to state its range now. Let's try and state its range. So let's first find out what f of g is. So here we have f of g of x. F of g of x is the same thing as f of the square root of x, which is the same thing as square root x squared take 4, which is equal to x take away 4, right? Now we want to find the range of this function, yeah? Gonna have the domain. We have here the range, right? And we're gonna use our little method, yeah? First, we're gonna see if they're subsets of one another, right? If we have to reduce them, yeah? So if they're subsets of each other, let's first see. We have here f of g, which means here we have to have 0 to infinity, which is the range of this one, as a subset of the real numbers, yeah? Which is the domain of this one. That's true, yeah? We can show that's true. So here we have g, here we have f. So we know we're starting off from 0 to infinity, yeah? That means here, the range of g is also going to be from 0 to infinity. Then we do our little whee motion, and we get to 0 to infinity. Yeah? Then we have to sketch f with this new domain, right? To find out the domain of the composite. To find the range of the composite. So this is what f normally looks like. Remember, I only want one half of it. I only want this part of it here. Which means here, right, I get 0, 0, comma, -4, which is equal to, right, we get -4, comma, infinity. Does that make sense? Any questions, any comments, any concerns about this one so far? Any ideas? These guys are out of the friend group, probably above 2. Dude, they're all hating on each other, man. They are so mean to each other. I remember one kid got clowned on for getting like a 40, like a scaled 40 in methods. It's like, God forbid, bro. God forbid. Let him get his score. Let him get his score and like move on with his life, you know? Like, they all, like, people just give each other so much shit so quickly. Like, you know. Anyway. So here we get -4 to infinity as our range for this function. So here, for this function, its range is from -4 to infinity. Yeah? Any questions about that? Any comments? Any concerns? Any ideas? Now, to explain why this doesn't exist, we just have to show that here, the range of f is not a subset of g of x's domain. Yeah, so D's domain. Well, what's the range of f? Well, the range of f is going to be from -4 to infinity. Yeah, is that a subset? Oh, and then here, well, our range of this one is all real positive values, including 0, right? They're obviously not subsets of each other. If we draw them on our number line, this is going to be the domain of G, and this is going to be our range of f. And do you see how this one isn't inside this one? That means it's not a subset. Does that make sense? Any questions, any comments, any concerns about that at all? So, that's that question. I think that's what we're building our understanding slowly. So we first built the skill of creating the rule of this composite, yeah? Now we're going in and plugging values in, yeah? Afterwards, we've gone about finding the domains of these functions. How do we find the domains of these functions, yeah? The domains of these functions, right? The first way is just that, again, if it's already a subset, it's just the domain of the original function. It's just the domain of that inside function. And here, right, now we've gone about exploring, well, how do we find the range of these functions? The range of these functions is going to be, well, whatever our table shows us it is, yeah? So essentially, f of x is just sketched over this domain to get our range, yeah? Is that making sense? Any questions, any comments, any concerns about that? Yeah? So, like, basically what I'm saying here is that the range of the domain of the composite is just the domain of the inside function. And the range of the composite is just the range of the outside function, given the restriction by the composite, right? Given the restriction on the given by that range of G, yeah? It's weird, isn't it? It's a very weird topic. It's very hard to wrap your head around. But it's a very interesting topic. I think it's one of the most interesting topics ever. I find it so interesting. Like, whenever you sit down and you do these, do you have any questions, any comments, any concerns, any ideas? If you do, you can type them in the chat. I don't really mind. I'll answer anything. Hell, give me a direct message if you're not confident with that. If you're not confident, right? If you aren't, you can, I don't know, play the hit game on my, I don't know, man. What were you expecting to do? What were you expecting me to say? So, we'll get to G. We'll get to question 6. Yeah? Question 6. Here. It says, here, find f of G and find G of f. Or here. Holy shit. Okay. So, here, f of G. Yeah? And then state the range of both in both cases. Yeah? So let's first find out, well, what is the rule first? So we first want to find the rule, and then we want to find the range. Let me just quickly grab an eraser and erase that stuff out. So here we start off, and we have f of g. F of g is in the game, right? So we have here 1 over 2, right? Oh, no, let me slow that down a little bit. So here we have f of 1 over 2x take 1, yeah? Which means we can rewrite this one as 1 over 2, 1 over 1 over 2x plus 1, yeah? Plus 1, yeah? Most people get very confused at this point. They're like, what the hell am I meant to do this? Well, it's just 1 divided by 1 over 2x plus 1, which is the same thing as 1 times by 2x plus 1, yeah? So this just ultimately turns into a half over 2x. Oh, wait, no, this is a minus, sorry, this is a minus. So 2x minus 1 plus 1, yeah? Which means these ones cancel out. We're just left with x, right? So that's our domain. That's what this is equal to. This is equal to x here. Now we're trying to find the range of each one of these. How can we find the range? That's the real question, yeah? And we're going to use our same method. We're going to use the same method we always use, yeah? That's the really nice part about composites, is when you can create a beautiful method for it. It just works each time. There's no way, like, I haven't found anyone who's disagreed with my method. They've disagreed whether it's the most efficient, and sometimes you can just sort of see the answer. But the thing is, sometimes can we be expected to just see the answer, you know? Like, some people can just see math. Like, you know, that's I'm very happy for them. But it's not an ability that everyone has. So here, right? We write in that domain of G, yeah? Right? Like obviously the first thing we'd have to check is if they're subsets of each other. So here, right, the range of this function. So here the range of this function is just going to be all reals not including 0. Now, that is very much a subset of the domain of the domain of f. All reals not including 0 is going to be a subset of all reals not including 0. Makes sense, right? So we type in all reals not including 0, and then this one goes down and goes whee, and we get all reals not including 0. And then we sketch this function, right, over this domain. Well, we'll sketch this function over this domain. It's going to look something like this, right, with an asymptote here at y equals a half. So we're going to get here, bro, turn off this shit. Bro, I've heard this ad like a million fucking times. I really hate it. Anyway. So that means this range is going to be, that was a crash out and a half, bro. So we get here, that's the range. So for this composite, it's actually going to be all reals from, all real numbers, not including a half. Again, I'm just using the same method. I'm not creating any new maths. I'm using the maths that I know. I'm not doing anything revolutionary. I'm not doing anything fantastical. I'm not doing anything like that. I'm not pulling anything out of my ass. I'm doing the same thing over and over again. Yeah? And again, it's like, it looks very foreign to a lot of people. When they first look at it, they're going to be like, oh, what the hell am I doing this? Right? It's very foreign to them. But when you get used to it over time, it becomes beautiful, right, to look at. So, here, right, we'll look at this one, right? Part B, yeah? We do the same thing again, right? We have here g of f of x, right? Which is the same thing as g of 1 over 2, 1 over x plus 1 over 1, yeah? So that means we get here 1 over 2 brackets a half brackets 1 over x plus 1 over, so we have brackets, take away 1. So there's a lot of brackets being used there, yeah? So I can see this 1 and this half cancel out with one another. So it's like 1 over x plus 1, take 1. So I cancel these out, I get 1 over x. And if I think about it again, I get 1 divided by 1 over x, which is the same thing as 1 times x, yeah? I'm just using that. I'm using stuff that we've learned before. We get x, yeah? So we get x for this one. Oh, it was pretty interesting. And next time I get on stream, I'll probably deal with the idea of composite functions next. I mean, inverse functions, and what the examiners are looking for there. Yeah? Because they're looking for pretty interesting stuff when it comes to composites. So we get the same value again. Yeah? Now, you want to find the range of this function. Well, the range of this one. This is its domain. So, first, I'm going to check if this is its domain. Yeah? So first, I'm going to... what's it called? I'm going to find the range of this one. The range of this one is just going to be all real values, not including a half. That's the range of this. Yeah? Is this a subset of this? Yes. They're the same. They're the same interval. So they're subsets of one another. I can use the number line again if I need to. Yeah? I encourage you to use the number line. But I'm not this time. Yeah? I'm going my big boy boots. I'm able to avoid using that number line. It's because I'm practicing. Yeah? So I have here F. I have here G. So I have here... this one is from 0 to infinity. That's what its domain is. Its range. All real values, not including a half. Right? Then I go, whee! I go from all real values, not including a half. Right? And then I sketch G using this domain. Right? G, it's just going to look like this. Yeah? Where it has an asymptote at y equals 0. And here it's going to have an asymptote at x equals a half. So we get here all real values, not including 0. So, does that make sense? Any questions, any comments, any concerns about that? Any ideas, any thoughts, any questions about it? I think it's particularly a very, very interesting thing. Yeah? So, I'm going to rub all this stuff out. So I'm going to rub all this stuff out here. And we're going to have a look at this question here. Why does it not exist? So we're looking at the existence questions. Yeah. So G of F. Yeah. Well, first, what is the range of this function? The range. This is what it's going to look like. Yeah. Over this domain. That's what it's going to look like. Yeah. The range of this one is from -2 to infinity. Yeah. The domain of F of G is going to be this. So, well, we have to just effectively prove that this is not a subset, yeah? We can show this one is not a subset by drawing it on a number line, right? So if I draw this one on a number line, I get, well, this is going to be the domain of G, right? This is going to be the domain of, this is going to be the range of F, and I can see that this isn't inside this, yeah? So they're not subsets of one another. Yeah. Does that make sense? Any questions, any comments, any concerns about that? So, now then, right? Now it's asking me, find f of g and sketch its graph, right? So, f of g, yeah? Well, I can find out what f of g is pretty easily, right? That's the same thing as f of g of x, which is the same thing as square root x squared take 2, which is the same thing as x take away 2. Crazy, right? I know. Now, right, to sketch this one, I'm first, because the question doesn't ask me if it's defined or not, yeah? So I'm going to check whether this one's range is a subset of this one's domain. So the range of this one is just going to be from 0 to infinity. It's just a regular old square root graph. But, and is that a subset of this? Let's check it. Let's check it real quick. So this is going to be the domain of f. This is going to be the range of g. Yeah. And we can see they're subsets of one another. Yeah. So that means this is the domain of the composite. So we can just sketch this graph over this domain. So this graph is going to look something like this. It's beautiful. It's pretty simple. It's very nice and straightforward. So we get here 0 to -2. And that goes all the way to infinity. So this one goes 2, 0. Any questions about that? Any comments? Any concerns? Any ideas? Any thoughts about all of that? It's quite interesting. I always find it pretty interesting how I have a lot of students who come up to me and they always tell me that they find composites one of the hardest things ever. Yeah. I don't think it's too difficult. And one of the reasons I think it's not too difficult is because how people teach it, it's very they explain it very difficulty, and they make it look really hard, and then students get flustered and they're like, oh, I don't know what the hell to do. Yeah, because most people don't really know what the hell to do. It's pretty freaking hard. Yeah. It's hard at the beginning, but trust me, it's the same process over and over again. Yeah, like here, right? Question 8. Show that f of g is not defined. So f of g is not defined, right? If f of g is not defined here, right? I need to show that this one's range is not a subset of this one's domain. Yeah. So, what is this one's domain? It's from negative infinity to 3. Yeah. Well, what is this one's range? I have to sketch this one. Yeah. That's what it's going to look like. Yeah. And here I can see that this one's range is from 1 to infinity. So I can say here that 1 to infinity is not a subset of negative infinity to 3. Yeah? And I can prove this one to myself. I can look at a number line and I can see, well, here's 0. I'll put 1 here and I'll put 3 over here. Oh, wait, no, I'll put 3 over here. This is going to be, so this is going to be the domain of f. This is going to be the range of g. Yeah? And what I see here is that this one here isn't inside of this one. So they're not subsets of one another. Now, right? The next part of the question says, find a restriction on g such that it's defined. Well, how do we do that? Let's, again, we'll draw out my little box. We have a domain. We have a range. Draw the lines here. I'm gonna put this one here. I'm gonna put G. I'm gonna put F here, and here I'm gonna put this one down the bottom. Yeah. So we have our little columns here. Yeah. So first, what I do is, what's the domain of F? It's from negative infinity to 3. Yeah. So I get negative infinity to 3. What's the range of G? I get that one as 1 to infinity. Yeah. I want to find where these two are subsets of each other. So we want to find where they intersect one another. Yeah. So here is 0, here's 1, here's 3. This is as it goes backwards. And this one is as it goes forward. Yeah. So this is the range of G. This is the domain of F. Yeah. Where they intersect each other is between 1 and 3. So here I'm going to put 1 and 3 here. I'm going to put 1 and 3 over here, right? Just in case I need it for later, yeah? To find the range of this one, well, I need to figure out, well, what does it look like between 1 and 3, yeah? Wait, this is -1, so -1. This is -1. That's why it was so funky, man. It's -1, there you go. So this one here is between -1 and 3. I want to find out what it looks like between -1 and 3, yeah? So this is now the new range of G, yeah? So I'm gonna sketch G, yeah? So this is what G looks like. And I only want it between -1 and 3. So to get it between -1 and 3, well, I can see I have to cut it off at these 2 points. And here it's at the turning point, so I don't really have to worry about it. Essentially, I just want this section of the graph. Yeah? Including these 2 endpoints. Yeah? I can calculate those 2 endpoints. I can do 3 equals x squared, take away 1, x squared, take away 1. I get here x squared equals 4, which means x equals plus or minus 2, which means this point here is -2, this point here is +2, which means now, for this to be true, the domain of this has to be from -2 to 2, which is now the domain of the composite. It's the domain. It's wonderful. It just works out so nicely. So what did I do there? Yeah? I found the domain of F. I found the range of G. I found when they're subsets of each other. And I put that subset, that intersection, into these 2 boxes. I use this range and I sketch G over this range to get our domain. And then from there I get my answer. It's pretty interesting math, isn't it? So, I'm going to end off the stream here. There's more questions to do on composites. There's more stuff to look at. And I encourage you, if you would like to, continue going on. I would skip question 11. I don't think question 11 is very useful. Question 9, 10, and 12. Quite wonderful. You need more composite function questions. There's more to be found here. Question chapter 7 of the Cambridge textbook. The other place we can find these is we can go on to the VCAR website. We can go on to the Dynamic Education website. That is dynamiceducation.com.au questions for fun. And here you'll find a thing called preliminary studies. In there you'll find all sorts of questions about composites, about inverses, about all this stuff. And this is real exam style questions. So this is stuff you can really expect on the exam. So I'll leave you all here for now. I hope you have a good night, and I'll see ya when I do. Good day, sir.